In this problem, we are told to use the node voltage method with this circuit, and we are going to find the V0 in this circuit. We also want to find the power absorbed or delivered by the 3 amp current source. To use the node voltage formula, we have to look at currents. In the notes linked below, there is an example that we have that looks like this. And the equation for the example is this right here. This is how we would do it. And this is kind of how we did it in the previous video. That's in the playlist below. However, there's a slight difference here. We notice in our circuit diagram that's given, we don't have a part right here for voltage. However, this is not necessary, and the only reason why we have these steps right here is because we have 2 voltages. Since we only have 1 voltage right here, that means we're only going to need 1 step. So we are going to be looking at the node that is right here. We can combine these 2 resistors because they are in series and the current flowing through them is the same. However, the voltage differs. So we will have a 10 ohm resistor here. We are going to follow this instruction right here. At node 1, which is our only node, we have V1 minus the voltage source. So our V1 is going to be this V0. We have V0 minus our 60 volts because this is our voltage source. And this is going to be over the first resistor. This first resistor is the resistor in between our node and our voltage source, so it's 10. To explain this, what's happening is that since these resistors are in series right here, the voltage that is going to be at this V0 right here is going to be less than our source voltage. That's why we have to take the voltage that we're going to be looking at and subtract the source voltage. And also because the Kirchhoff's law states that anything going into a node is negative, and then anything going out of a node is positive, which is why our V0 is the positive portion. Continuing with this, we are going to look and say that we have a plus V0 over our R0, which is 5 ohms, because we go like this. Now we are looking at this side right here. All we have is a 3 amp right here. We can see that it is going out of our node, so it's going to be a plus 3 amps like this, and this is all equal to 0. Now we're going to try to solve for V0. We're going to multiply everything by 10, that way we can only have numerators. If we do that, we are going to get the following right here. To simplify this further, we are going to add everything that's similar. We're going to have a 3 V0, and then we're going to move our constants to the right, so we're going to get a 30 amps. And then we're going to divide both sides by 3, so we're going to get our V0 is equal to 10 amps. I messed up a little bit on the units here. When I said I multiplied everything by 10, I meant I multiplied everything by 10 ohms, like this. So that means our 30 amps right here would be actually 30 amps times ohms. So when we move it over, we would have this. And amps times ohms means that our V0 is equal to 10 volts. So our answer for V0, part A, is 10. Next, we're asked to find the power absorbed or delivered by the 3 amp current source. Well, if we look at our 3 amp current source, I'll draw this in red. From our node to our current, power is going through it. The same way that our current is flowing through here, that means it is being absorbed. And since it's being absorbed, we're going to have a plus. Now, the formula for power, or one of the formulas for power, is voltage times current. We know the current to be 3 amps, but we also know the voltage. In fact, we just found it because the voltage right here in parallel is the same throughout. So whatever voltage is down here is going to be the same voltage that goes through here. And we found that the voltage that's right here to be 10 volts. That means the voltage going through here is 10 volts and the voltage going through here is 10 volts. That means our power is equal to 10 volts times 3 amps or 30 watts because volts times amps is watts. So the answer for part B is 30, and this is how you do this problem. If you want more problems like this for homework or for exam studies, there will be a playlist linked below as well as notes that will help with the homework or studying for an exam.